Hi everyone, so we are on the N.RN.2 level 1. There's going to be 3 lessons within this level 1, and all of the lessons are going to be related to exponents and completing exponent rules. So in this lesson, we are going to learn about 0 as an exponent and negative exponents. But before we jump straight into that, I do want to kind of give you guys an idea of how exponents work, because we have all known that exponents are repeated multiplication. So for example, 3 squared is the same thing as 3 times 3, which is 9. But you may not know that exponents are all about patterns. And so I'm going to show you exactly what the pattern is when we're using exponents. So for example, if I wanted to do 3 to the 3rd power, that is 27. That's 3 times 3 times 3. Then if I wanted to do 3 squared, that's 3 times 3, which is 9. And if I wanted to do 3 to the 1st power, that is 3. Okay. Now I'm going to show you what is happening between your finalized answers here. To get from 27 to 9, what's really happening is we're dividing by 3. We're dividing by the base of 3 here. To get from a 9 to a 3, we're dividing by 3. Okay, so if I take this and I divide by 3 again, that would give me 3 to the 0th power, which a 3 divided by 3 actually gives us that 3 to the 0th power is 1. Which if you tried this in your calculator, if you type in 3 to the 0th power, how you would do that is you would type in 3, and then you would find this upward arrow button, that's called a caret, and then type in your exponent of 0, you should come out with that being a value of 1. So when we have 0 as an exponent, we wind up with a value of 1, and that will work for any other one. I'll show you. But now, let's say I wanted 3 to the negative 1st power. I have a negative exponent, which is probably something you've never dealt with before. Well, let's keep following the pattern of dividing by 3. If I take 1 and I divide by 3, I get 3 to the negative 1st power is a 1/3. And same thing if I do 3 to the negative 2nd power, that's really 1/3 divided by 3, which is the same thing. A 1/3 divided by a 3 is the same thing as a 1/3 times a 1/3. So I would wind up with 1 over 3 to the positive 2nd power, which is a 1/9. Okay, so a couple of things that we've learned from this scenario is that when we have 0 as an exponent, we wind up with a value of 1, even if it was 100 to the 0th power. Type that in your calculator right now. You should wind up with 1. All right. And then another thing that we learned is that if we have a negative exponent, what that really does is it sends for example, a 3 to the negative 2nd power sends the 3 squared into the denominator, and it now becomes a 3 to the positive 2nd power in the denominator. If I had a 3 to the negative 3rd power, what's that going to do? That's going to send my 3 to the 3rd power into the denominator of my fraction, and it now becomes a 1 over 3 to the positive 3rd power, which is a 1 over 27. So exponents are all about patterns, and hopefully you learned a little bit about exponents just by that little simple example. So 0 as an exponent, you can write down for every non-zero number, a. If we take a to the 0th power, we should wind up with a value of 1. So 100 to the 0th power is 1. 1,000 to the 0th power is 1. 798 to the 0th power is 1. Any non-zero number raised to the 0th power will be 1. So now some of you guys might be thinking, well, what about 0 to the 0th power? So 0 to the 0th power, we just learned that by patterns, if we take anything to the 0th power, we get 1. But we also learned that by patterns, if I had a 0 to the 3rd power, that would be 0. If I had a 0 squared, that would be 0. If I had a 0 to the 1st power, that would be 0. So by this pattern, 0 to the 0th power would be 0. And since we have 0 to the 0th power equaling 2 different values, then in math we call that undefined. We can't define what 0 to the 0th power is going to be because it contradicts 2 different patterns. So that's why I said for any non-zero number, a to the 0th power would be 1. So if we have 0 to the 0th power, that's going to be undefined. All right. And then negative exponents for every non-zero number a and rational number n. So a rational number is just a number that ends. It's not a decimal that goes on forever and ever. If we had a to the negative nth power, then what we do is we move this a to the negative nth power into the denominator of a fraction and put 1 in the numerator, and then the a to the nth power now becomes positive. And if I had 1 over a to the negative nth power, how we would do that is we would just move that a to the negative nth power into the numerator, and it now becomes a positive a to the nth power, the positive nth power. So if we are dealing with negative exponents, if it's in the numerator, like this one was here, then we move it down into the denominator to make it a positive exponent. And if it's already in the denominator, then we move it to the numerator to make it a positive exponent. All right, so now we're going to practice. So numbers 1, 2, and 3, we're not actually finding the value of the expression. We're just determining, is the expression, the value, going to be positive or negative? Well, if I have a negative 2 to the 3rd power, that's really a negative 2 times a negative 2 times a negative 2, which actually would give me a negative value. Because if you have three negative numbers multiplied by one another, you get a negative number. All right, negative 2 to the 2nd power. This one's actually tricky. If you type this into your calculator, you'd get a negative number, and it is in fact negative. Because this is the same as a negative 1 times a 2 squared. Because this negative is not in parentheses, it should not be raised to the negative, or to the 2nd power. So this would be negative. However, I'm going to show you something. If I had a negative 2 to the 2nd power like this negative is in parentheses, so the negative is being raised to the 2nd power. So you have a negative 2 times a negative 2, which would give you a positive value. So if the negative's in parentheses, it does have that exponent attached to it. But if a negative is not in parentheses, like we saw in number 2, then the exponent is not attached to the negative number. So in number 3, we have a negative 3 to the 4th power. So this is a negative 3 times a negative 3 times a negative 3 times a negative 3. Because the negative's in parentheses, it's going to be attached to that exponent. And if you have an even number of negatives being multiplied by one another, then you wind up with a positive value. If you have an odd number of negatives being multiplied by one another, then you wind up with a negative value. All right, so now we're going to do some problems here. We're going to simplify each expression, so actually find the value. And it does say to simplify means that we should have no negative exponents at the very end. So we want all positive exponents. So for number 4, I have a 1 over and then a 2 to the 0th power. Anything to the 0th power is a 1. So I really have a 1 over a 1, which is just a 1. That's our value. All right, number 5. This negative 1 is being attributed to both the 3 and the 7. So I have a 3 to the negative 1st power. I have a 7 to the negative 1st power. So the 3, in order to make it into a positive exponent, since it's in the numerator, it needs to be brought down to the denominator. And to get the 7 to have a positive exponent, it's in the denominator, it needs to be brought to the numerator. So I would have a 7 to the positive first power, which is just a 7, over a 3 to the positive first power, which is just a 3. So I have a 7/3. That's it. All right, number 6, what we're going to do here, -5 squared is the same thing as a -5 times a -5 because the negative is in parentheses, so it does attribute to the squared. It attaches to that exponent. And a -5 times a -5 is a 25, positive 25. All right, number 7. Now, number 7's a little bit tricky. So one thing that we can do is we can do an 8 divided by a 2, which is a 4. That 4 would go in the numerator, and then I still have this s to the -3rd power in the denominator. Now that s to the -3rd power, we need to make it into a positive exponent. So since it's in the denominator, it will need to be brought into the numerator in order for it to be positive. So I have a 4s to the +3rd power in my numerator, and then there's no number left in the denominator. Technically, there's a 1 in the denominator, but we don't have to write that. So this is my finalized answer here. Again, no negative exponents. All right, number 8, what we want to do here is 1, I can simplify the d to the 0th power. We are going to assume that all variables are going to be non-zero numbers, so the d is going to be a non-zero number. So a d to the 0th power is a 1. So I really technically just have a 6a to the -1st power, c to the -3rd power, and if you want to write it over 1, you can, but you do not have to. I'm not going to. All right. Now, I have, technically this is a 6 to the +1st power, so that 6 already has a positive exponent. The a has a negative exponent, and the c has a negative exponent. So both of those will need to be dropped down into the denominator in order to have a positive exponent. The 6 stays in the numerator, so I keep the 6 in the numerator. A to the positive or to the -1st power goes into the denominator. It becomes a to the +1st power, or just an a. If you want to write that exponent of 1, you can. It's up to you. And then the c also drops into that denominator and becomes a c to the +3rd power. This is your final answer. All right. Then number 9, a 12 to the 0th power is a 1. You can write that 1 if you wish, or you can just cancel it out because a 1 times a t to the 7th times a u to the -11th is just this. Now the t to the 7th, it already has a positive exponent. The u to the -11th needs to have a positive exponent. So we need to drop that down into the denominator where the t to the 7th power remains in the numerator. Since everyone has positive exponents here, then that is completely simplified. All right, and that is your first lesson. Remember, an exponent of 0 gives you a value of 1, and then a negative exponent either brings it into the denominator, or if it's in the denominator, it will move it up into the numerator. Move on to lesson number 2 now.